So lesson 32, calculations with acceleration. We'll be able to perform calculations with acceleration. This is straight off what we did last lesson, but it's normally what I would do. If we had a double lesson, I would have taught it all at once. But because we have two singles, I thought I would break it up. What we're going to do is learn about how to do some calculations rather than just like knowing what it is. So what is acceleration? Acceleration is this idea of how long does it take an object to change its speed. Does it change its speed really quickly? Like, can it go from 0 to 100 kilometers an hour in 2 seconds? Or does it change it slowly? Does it get from 0 to maybe 10 meters per second in like 3 hours? Like, how quick is it? To do that, we use this measurement here. Final speed minus initial speed over t, the time taken. It means speeding up or slowing down. So whenever I say, you know, this object accelerated, I want you guys to think, oh, it's probably sped up, maybe it slowed down. We had two examples here. When the car gets hit with a positive acceleration in the same direction, it increases its velocity, which makes it go faster. When this little car is hit with a negative acceleration, it's going in the opposite direction, its velocity gets smaller, and so it moves slower. That's what I wanted you guys to understand. When you hit with a negative acceleration, you get slower. So what we're going to do today is we're going to be really going through what these sort of ideas mean. What does it mean to have a negative acceleration? What does it mean? How do we calculate these accelerations? We're going to start off with some easy questions here. Is this an easy question? That's not an easy question. Here's an easy one. That's also not an easy one. Oh, all right. Let's hold on a second, guys. I'm going to change. I'm going to make a question. I want to make one that's a bit easier because I don't want you guys to be, you know, getting this really difficult question for your very, very first question. Let's change this question here. Give me a second. We're going to change it. Slows down to. Sorry, I'm just changing a question. So just talking about, well, don't talk about yourselves. We'll go in. Yeah, we'll go with something like 2. Yeah, there we go. Sorry about this, guys. I know you can't see what I'm doing. It's just I'm just trying to make an easy question for you guys to start off with so that we're not having to do the hardest question in the world. And then what we'll do is probably later on I might actually go through some actual questions with you. Now I've got to share the damn screen. Okay, here we go. Now, here's the question. Oh, what happened? Oh, God. Why?
Oh,
just why? Just tell me why. Huh?
Why? Tell me why.
Why don't you want to watch it? We're not. Oh my God! I'm more impressed that you actually know that song because it's a 90s song. That's a song from my youth.
What are you talking about? That song's so old. Oh, it's known. Tell me why ain't nothing. Anyways.
All right, here we go. Here we go. You are skiing down a slope at 8 meters per second. So that's your speed. And then you start slowing down to 2 meters per second. To 2 meters per second in 3 seconds. Sorry about the spelling, but we're just going to make do. We're going to calculate the acceleration. So let's do this. What is the final speed? Can you guys tell me what's the final speed?
3 seconds.
Wait, what? The speed?
Yeah, what's the final one? What do we end up doing? What speed are we at the very end? You guys who aren't talking, who haven't got earphones, can say in chat. What is the final speed?
I don't know.
2 meters per second.
2 meters per second. Exactly.
Okay.
Well, look, right? At the start, you were going 8. At the end, you were going 2. So what's the final speed? The end speed? 2. What's our initial speed? What's our starting off speed?
8 meters per second.
8 meters
Yeah.
per second. Now, how long did it take us to change speeds?
Um.
How long did it take to go from this one to this one?
3 seconds.
3 seconds.
Beautiful. So now if I want to calculate my acceleration, right, all I need to do is I need to go A equals my final speed, which is 2, minus my initial speed, which is 8, divided by the time, which is 3. 2 minus 8 is negative 6 over 3. Negative 6 divided by 3 gives us negative 2 meters per second squared. And that's how I find the acceleration. Do you guys want me to do another easy one, or do you want me to jump on to doing a harder one?
Do the one that you're on the next slide.
Harder one for the boys.
The next
Yeah,
one's
boys.
The
Do
next
the
one's a
next
bit
slide.
harder. So yeah, but I will point something out here. See how this is negative here?
Uh-huh.
That means we know that the object is slowing down. And that actually makes sense because we know it's slowing down. Okay. Now, I'm actually going to do a you know what? I'm going to do one more easy one, and then we're going to do a hard one. Okay. So we'll do an easy one. We're good, but I'm going to have to make it up as I go. Okay. So give me a second. All right. Let's go with David is in a stolen car. He is driving at, we'll go with
Stolen car even.
Bro, who did this?
Bro, that's GTA, bro. Automatic 5 stars.
He is
5
stars.
stars for driving in a stolen car.
at 10 meters per second when
Wait,
he
sir.
sees, yep,
Do you know how many examples we're going to be doing of this?
probably 4. So we've done 1, so we've probably got 2 more after this.
Okay, like, wait, am I able to like just copy one example?
You should probably copy 2, but this one, and you can probably skip this one if you want. When he sees a police car, when he sees the police and
I need to go
changes
to the loo. Can I go?
the
Like I'm being around. Can I go bathroom too?
to maybe let's say like
Oh.
30 meters per second
30 minutes? This man's wanted. He's on the FBI.
in like
This man is something else.
Let's say it takes him about
Bruh.
let's say it takes him about 15 seconds to do that, right? In 15 seconds.
Okay, you know he's not driving in a sports car.
Okay, let's solve this. First thing, can you guys tell me what is David's initial speed?
10.
Meters.
What is his final speed?
30.
30 meters.
How long does it take to change from 10 to 30?
15 seconds.
15. Lol, I thought that was never mind.
So therefore A equals your final V minus your initial V divided by T, which is time. What?
Who's that, sir? Can I say hi?
I'm bringing the tub back. I was going to do it after school. Oh, sorry, I'm just getting someone asking me a question.
Let us say hi. Let
So
us say hi, sir.
Definitely, Mr. Silver.
when you work this out, 30 take away
Take away 10,
10 divided by 15
15.
is going to be
20
20
over
15,
15.
which is I think going to be 1.3.
1 point.
One
Wait,
point.
so
I'm not good at math.
No, wait, no.
Let me
Wait,
Yeah, it's
bring up my
1.3.
calculator.
1.3.
Oh, well, sir.
Yeah, I was right.
Martin.
1.3
Martin, sir.
Man, the math
meters
genius.
per second squared. So, and you can tell as well because it's positive, right? That means it's going fast.
Faster.
So that's the clue that you've gotten, and it sort of makes sense that if you've seen the police, he would speed up.
Obviously, you would drive off and
Well, I
speed
mean,
off.
David would speed up. I mean, maybe
In
someone
his
else
stolen car.
in a
his
stolen
stolen
car would speed up. Yeah.
wait, so
Yes.
am I tripping? But was it like on the other slide? Was it the formula initial takeaway final?
No.
No, it's final
we
takeaway
did-
initial.
But in this one, the final speed was less than the initial. So that means it comes out to be negative. But here, the final speed
Was greater.
greater than. So therefore, it changes. Yeah, you're getting it. Pretty good.
So
So
I'm actually
now,
tripping.
Ah, yeah.
so now let's quickly let's do the last question. Well, not the third question. This one's a bit different. So just be prepared. You are driving at 20 meters per second, and then you accelerate at 5 meters per second squared for 4 seconds. What is your final speed? Now this is a
Hold
bit-
on. You're driving at 20. Accelerate.
Yeah. So here's the question: if you accelerate, are
Don't you speed off?
Yeah, at the end, are you going to be faster or slower?
Fast.
Faster. So you want to work out what your final speed is, okay? What is the final value that you get from this measurement? Now we can calculate that. How we calculate that is we would go, we don't want to know A anymore. We want to know the final speed. So I'm going to multiply both sides by T. AT equals final minus initial.
Wait, what? Why are you so are you times it? Oh, yeah.
So I'm just doing some basic maths here. I'm just moving that T to the other side. And then what I'm going to do is, because I want to know what the final speed is, I'm going to add initial speed to both sides. Because that'll cancel that out. So what I end up with is this. Your final speed is equal to your A times T plus your initial. I shouldn't have swapped those around, I'm sorry. A T plus your initial speed equals your final speed. Now, can you guys tell me what's the acceleration?
What?
5.
5 meters per second squared.
What is the time?
4 seconds.
4
4
seconds.
And what is the initial
20.
speed is 20. So if I substitute all these values into here, I get 5 times 4. 5 times 4 plus the initial speed, which is 20.
Wait. So, oh, yeah.
This
Okay.
5 goes where the A is. This 4 goes where the 4 is. This 20 goes where the initial speed is.
Oh, lol. Yeah. Nice. Yeah. Sorry. I love this stuff.
Then that's going to be 20 plus 20. So our final speed,
Wait, what?
It's like y_m, like
Oh.
y equals m. What is it called? Linear graph.
Y equals mx plus c. What we're doing, right, Brendan, and thank you, I know that you might, thank you, sort of letting me know that I'm going a bit too quickly here, is that we are substituting in, instead of, let me see if I can get a different color. Instead of A, we write down 5. That's why there's a 5 there. Instead of P, we write down 4. That's why there's a 4 there. Instead of initial velocity, right, we write down, instead of initial velocity, we write down 20. So that's why there's a 20 there. And then after we substitute that, we can solve it to get the final speed is 40 meters per second. No, made a mistake. 40
What?
meters per second. Not
Wait, what?
squared. The unit
Oh yeah.
has to be speed. So that's the third example of how to do these types of questions. And the last example is a bit of a weird one, but it's still something I wanted to show you guys. The last example is a picture example. You guys should be able to do picture examples. They're just as easy to do as these ones. Whoops, ignore that, ignore that. So, acceleration is the gradient on a velocity time graph. So we're going to do this, and this is the last example, and then we're done.
Isn't that like negative on the bottom?
Yeah. So let's grab a look here. Let's put some numbers in here. Let's call this one in seconds. We'll call this 1, 2, 3, 4, 5, 6. And let's say, let's keep it easy. Guys, how does that sound?
Yeah.
Let's call
Yeah,
this one
sounds great.
is 1, 2, 3, 4, 5, and this is meters per second. And this is 0, -1, -2, -3. Okay, so what's going on here? In this time, this object is moving away, but it's moving away and it's moving away really quickly, but then it's moving away slower and then slower, and then it stops moving away. How do I know that it stops moving away? You see here, the velocity is 0. It just stops moving. Then it starts moving down. It starts moving down or backwards faster and faster and faster. This could be like a yo-yo, right? You could have a yo-yo that's going up and then it's going down, or you could have a ball that you throw in the air and initially it goes up really quickly, but then it starts to slow down and it comes back down. Any of those will do. There, any example, you might have you might be rolling a ball up a hill. And initially you roll the ball up a hill and it goes up really quickly, but then it stops and it comes back down. So how do we measure the acceleration? Well, the acceleration is the gradient. Now, and the reason it's the gradient is because how do I work out the gradient? Well, let's do this for this one here. We've got a rise, we've got a run. The rise in this question is 1, 2, 3, 4, 5, 6. The rise is -6. What's the run? How far have I run by?
I don't know. 3?
3.
Okay.
1, 2, 3. So therefore, the acceleration is rise over run, because, and that's going to be -6 over 3, which is -2 meters per second squared. That's it. Now, I know some of you guys are probably unsatisfied with that. They're like, whoa, 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 this is completely different to what we just did before. And I would say it's not. Let me show you why. Let's take this value here and this value here. I'm going to show you just this in a little bit of a different way. Okay? So if I take those two values there, let's say, let's call this one the initial speed. That's 3 meters per second. The final speed, that's -3 meters per second. Final speed, -3. Okay, and the time, well, it does that in 3 seconds. So A equals final speed minus initial speed over t. By the way, I've gotten lazy here. Final speed was -3 minus 3 divided by 3. It's going to be -6 divided by 3, which is -2 meters per second squared. So it's just a different way of doing the same problem.
Oh.
If you like this way more, by all means do it. But what I'm just
Hell
trying
no.
to say
Sorry.
is that if we're just finding the gradient. Now, the last thing I wanted to do was to show you guys, the two last things I wanted to do was to show you a picture. This is a picture of a person skateboarding. I want you to think about what happens when a person skateboards. When they go up a jump like this, what they do is they fly off and they go up in the air and they go up really quick at the start. And then when they get to the top, they usually hang out at the top for a little bit. And that's like where they're going the slowest. And then they start coming back down again. Okay? That is because, if you look at that, that's this graph. Initially, the person's going really quickly in the air. Then they slow down in the air. They almost like hover in the air for a second. And then they start to fall back to ground. That means that your speed is going to be negative. And that's why you've got this negative acceleration. The thing that's causing this negative acceleration, the thing that's slowing things down that go in the air and speeding things up as they fall towards the earth, is gravity. And we are going to be spending a fair bit of time next week talking about gravity and what does gravity have to do with acceleration? Because now that you guys know that it's accelerating downwards, you know, it's speeding up as the person falls down, and the acceleration is slowing that person from going up. You guys actually have almost enough information to understand how gravity works and why it works. But this was just the basics, and I thought I would show that.